In this video, we're going to go over section 3.2 from our textbook, which is on circles and quadratic functions. So we'll start with the standard form of a quadratic function that is given by p of x here. In this case, a, b, and c are all real numbers, and a here cannot be equal to 0. So like I said, this is the standard form of a quadratic function, and what makes this function quadratic is this term here, this ax squared. That is a quadratic term. If you remember from chapter 1 from our textbook, we went over linear functions. So recall that a linear function here. So a linear function is of this form here. And so this squared term is what makes our function quadratic. All right, so one method for solving quadratic functions is called completing the square. And so this allows us to transform the quadratic function so that it might be easier to work with and easier to identify certain characteristics for graphing the function. So here is our step-by-step process for completing the square. And so what we'll do is we will complete the square for this example here following this step-by-step process. So the first thing we need to do is divide each side of our equation by a. And so in this case, actually the first thing that we should probably do is identify what our numbers a, b, and c are in our quadratic function. So a is going to be 4, b is minus 8, and c is minus 32. Okay, so going back to step 1, we want to divide each side of our equation by a, so the coefficient of our quadratic term here. So that'll be our first step. So we'll divide both sides of our equation by a, which in this case is 4. Okay, so then we get p of x over 4. It's going to be equal to x squared, and then we have minus 8 divided by 4, so we're going to get minus 2x, and then minus 32 divided by 4, so we're going to get minus 8 here. Okay. The next step is we want to add minus c over a to each side. Okay, so this term, this minus 8 here, was c over a. So we're just going to add it to both sides of our equation. So then we'll get p of x over 4 plus 8 on this side, and then we just have x squared minus 2x on this side. Our second step here is we're going to add to each side the square of half the coefficient of x. So in this case, b over 2a squared is going to be minus 8 over 2 times a, which was 4 in this case. So we end up with minus 8 over 8. So we get negative 1 squared. So this is just equal to 1. Okay. So what we're going to do is we're going to add 1 to both sides of our equation. All right. We're going to simplify this a little bit. We'll get p of x over 4 plus 9 on this side. And then we want to factor the right side as the square of a binomial and combine the terms on the left. So we just combine the terms on the left here, but we want to factor the right-hand side. So factoring this, we know that we need our numbers to multiply to get positive 1 and add to get negative 2. So that one's pretty simple. It's just going to be minus 1. So what we end up with is p of x over 4 plus 9 on the left-hand side, and we got that by combining those terms. And then this here is x minus 1 squared. And so we completed step 4. We factored the right-hand side as a square of a binomial. So this is the square of a binomial. And this is because we have two terms here. So when we have two terms, we're going to call it a binomial. So I'll write that. All right. Now the second to last step is we're going to isolate p of x here. So the first thing to do is we will take away 9 on both sides. So we have p of x over 4 is equal to x minus 1 squared minus 9. And then to fully isolate p of x, we need to multiply by 4 on both sides. So we end up with p of x is equal to x minus 1 squared. Actually, this 4 is being multiplied by every term here. So we end up with 4 times x minus 1 squared minus 9 times 4, 36. Alright, so this is our p of x. And this is the form that we got when we completed the square by following this 6-step process here. So a benefit for this form is that it gives us a direct insight to the graph of the function. Let's consider the graph of p of x here in this form. So as we know from previous sections of our textbook, that this graph here is going to be a parabola that's going to be shifted horizontally h units and shifted vertically k units, as well as stretched or shrunk by this factor of a here. And so in this form, we will have all of that information. So this first observation here, the graph is going to be a parabola with this vertex here, hk, and the vertical line x is equal to h is going to be our axis of symmetry. So think if we were to fold this graph along this line, we would get exactly 2 halves. We also will know that the graph will open upward if a is greater than 0 and downward if it's less than 0. And the graph will be wider than our parabola if the absolute value of a is in between 0 and 1, and narrower if the absolute value of a is greater than 1. So let's look at this example. This is the same function that we just saw, that we just found this form by completing the square. So first, we can see that in this case, h is going to be 1 and k is going to be negative 36. Okay. We know this because we have a 1 here and a minus 36 here. And looking at this form, we do want to be careful of the sign of h. The standard form for this here is x minus h. So in this case, the only time we would get an x plus h is if our h value were negative. We would get x minus h, and so we would get a plus here. So if we have a minus here, that's the standard form, and this h here is a positive. Okay, so this tells us that our vertex is 1, negative 36, and that line x is equal to 1 is going to be our axis of symmetry. The next thing we're going to want to do is find the domain and range for this guy. Alright, so this is a polynomial, and we know that the domain of a polynomial is going to be all real numbers. There's not going to be an x value that will make this guy undefined here. Now for the range, notice that for x minus 1 squared minus 36 here, this term is always going to be positive, right? Because of this square here, we'll always get a positive term here. And so the smallest value that we'll output from this function here is if we were to plug in 1 here. If we were to plug in 1 here, we would get 4 times 0. And so our smallest output would be minus 36. Okay. So that's the smallest possible value we can get. And then plugging in all other x values, our output will go all the way up to infinity. Right, and just to make this clear, for example, if we were to plug in like negative 2 into this function, we would get so we'd actually get 0 there. If we were to plug in 1, we would get 4 times 0 squared minus 36, which is minus 36. Okay? So even if we were to plug in x values smaller than 1 here, so like -2 for example, we're not going to get anything that's smaller than -36. So this is our range of output values. We also have a positive a value here, so we know our graph is going to open upwards. All right. We also have, since we have this factor of 4 here, our graph is going to be wider than this graph by a factor of 4. Oh, sorry, it's going to be narrower since 4 is greater than 1. So our graph is going to be narrower by a factor of 4. We also know that it'll be shifted 1 unit to the right and 36 units down. All right, the next thing we're going to want to do is find the intercepts. So we know to find the x-intercept, we're going to set our function equal to 0 and solve for x. So we'll add 36 to both sides of our equation. Then we'll divide by 4. So we'll get x minus 1 squared is equal to 9. Now taking the square root of this guy, we get x minus 1 is going to be equal to plus or minus 3. So this tells us that in order to solve for x, we're going to have x minus 1 is equal to -3, or x minus 1 is going to be equal to positive 3. Right? So in this case, x is going to be equal to -2, and in this case, x is going to be equal to 4. So this tells us that these are the two x values that if we were to plug into our function would result in 0. So our x-intercepts are -2, 0, and 4, 0. Similarly, our y-intercept, we'll find this by plugging 0 into our equation. So in this case, we'll get 4 times -1, which -1 squared, which is just 4 minus 36. So this will give us -32. So our y-intercept is 0, -32. All right, so with that information, we can graph this. So we'll start with adding our information with our vertex and our x and y intercepts into this table here. So we know that our vertex is 1 minus 36. Our x-intercepts were -2 and 4. And we saw our y-intercept was -32. So with this information, we can do a rough sketch of our graph. We also know that we're going to have a axis of symmetry at x is equal to 1. So here. And our vertex is going to be 1, -36. So that'll be this point here. We saw our y-intercepts were -2, 0, and 4, 0 here. And then that's our x-intercepts, and then our y-intercept was 0, -32. So right about there. All right. So since this is our axis of symmetry here, this means we're also going to have a point here at 2, -32. So our graph is going to look something like this. Try to make this as straight as possible. Alright, so that's how we can use that form to plot a quadratic functions like this. Alright, so the next thing we're going to look at is what's called vertex formula. So the vertex of this quadratic function here is going to be this point here. And so this is the same thing as h comma k here. Remember when we had in the last example, this was our h value and this was our k value. And we found that by completing the square. Okay? But what we're saying here is that we can also use this vertex formula to find the vertex without completing the square. So for example, in the same example that we're looking at, our original quadratic function was this here. So a is 4, b is minus 8, and c is minus 32. Okay. So what we can do is use this vertex formula here to find our hk and make sure that it is the same thing we got when we were completing the square. So h is going to be this here, this minus b over 2a. So it'll be minus, and then minus b is minus 8 over 2a here. Sorry, and a is 4. Okay. So this will be, we have a minus negative 8, so it'll become positive, and on the bottom we have positive 8. So we just get 1 for h. You notice that's what we had here. And then for k, what we do is we plug in this h value into our function. So k is going to be p of h, which is going to be p of 1. So we get 4 times 1 squared minus 8 times 1 minus 32. So we'll get 4 minus 8 minus 32, which is negative 36. And that's exactly what we got here. Right, so this is another way that we can find our vertex without completing the square. So the next thing we're going to look at is extrema. So the vertex of our quadratic function is going to be the lowest point on the graph if a is equal to 0, or the highest point on the graph if a is less than 0. Like we saw in this last example here, this vertex would be the lowest point on our graph, and in this case we saw that a was greater than 0. Now if we have that a is greater than 0, the vertex is going to be called the minimum point on the graph, and we can find the minimum value of this function by evaluating the function at that point h. Similarly, if a is less than 0, then the vertex is going to be called the maximum point. It'll be the highest point on the graph, and we can find this maximum value by evaluating our function at that h value. Okay. So here are 2 examples of that. This is just our standard quadratic form. And so our vertex looks like this. It's going to be the lowest point on the graph. And we see that our a is positive, so our parabola is opening upwards. And on the other hand, we have that our a is negative, our parabola is opening downwards, and this vertex here is the highest point on our graph. Okay. So let's look at these examples here. We want to give the coordinates of the extreme point of the graph of each function and the corresponding maximum or minimum value of the function. Okay. So we have this quadratic function, and our a, b, and c are identified here. And so to find the coordinates of the extreme point, we know that we're going to have to find the vertex. Right? The coordinates of our extreme points are h comma k, which is the vertex. So for example a here, we're going to find that by completing the square. So we'll follow what we did in the very first example. We'll follow that 6-step process. So notice in this function here, we have a negative a value. And so we're going to divide both sides of this equation by whatever that a is. So we're going to pull out a -1 from each term here, and then divide both sides by -1. So we end up with p of x over -1 is equal to x squared minus 2x plus 6. Next thing we're going to do is subtract 6 from both sides. So we get minus p of x, because p of x divided by 1 is just minus p of x. Then taking away 6 from both sides, we get this here. Okay. Now the next thing we want to do is add this quantity, the b over 2a squared. In this case, b is 2 here, and a is -1. So we end up with 2 over -2, which is -1 squared. So we just get 1. Okay. So we're going to add 1 to both sides. And then what we want to do is combine these guys and then factor these guys. So we get p of x minus 5 on both sides, or sorry, on this side, on the left side. And then on the right side, we're going to factor this. So we need two numbers that will multiply to be 1 and add to be -2. So that'll be x minus 1. And then writing this as our binomial, this will be x minus 1 squared. Alright, now we want to solve for p of x, so we'll add 5 to both sides. And lastly, we're going to multiply both sides by -1. So we'll get negative x minus 1 squared minus 5. Okay. So this tells us that our extreme point is going to be our h comma k. And since we have a -1 here, that tells us our h is going to be +1. And then our k is going to be -5. Then remember, our minimum value is our function evaluated at 1. And we know when we plug 1 into this, we'll get 1 minus 1 squared, so that's 0, and we'll get -5. So our minimum value is -5. And we also get that just from this point here. You don't have to go back and plug anything in. And then something else to note is that since a is equal to -1, which is less than 0, our graph opens downward. Alright, so we found the extreme point, and the corresponding minimum value for part A. Now we're going to do part B, and for this one, what we're going to do instead is use vertex formula. So we have b is equal to 1 and a is equal to 3, and just to remind us, vertex formula is this here, so we're going to find minus b over 2a. So in this case, minus b over 2a is going to be -1 over 2, and then a was 3. Okay. So we get -1 over 6. Okay. So this is our h value for our vertex. And then remember, we're going to find our k value by evaluating our function at our h value. So plugging h into our function. So we're going to plug in -1 over 6 wherever we see an x in this guy. Alright. So this gives us 3 times 1 over 36. We're going to square the numerator and the denominator. So we'll get 1 over 36, and then we're doing this is to the power 2, so this negative goes away. And we're subtracting 1 over 6 and 4. All right. Taking a 3 out of both of these terms here, we just end up with 1 over 12. We want to get a common denominator for each of these terms. So we get this here. So this tells us our vertex is minus 1 over 6 minus 49 over 12. And so we know that our minimum value will be negative 49 over 12. And we know that this will be a minimum since a is equal to 3, which is greater than 0. So our graph opens upward. All right. And for the previous example, I said this was our minimum value, but this should be our max value because, like I said, the graph opens downward. So it looks like this. So we'll have a max value in this case, and this one opens upward, so it looks like this, and in this case we'll have a min value. All right. So the last thing we're going to look at is circles. So the set of points x, y in a plane, each of which is an equal distance called r from a fixed point h, k is a circle. So this point is going to be the center of our circle, and the distance r is going to be the radius. So center radius form of a function is given by this here, where, like we said, the center is our h and k, and the radius is going to be this r here. So this is what this looks like here. And then, because this is our center radius form, it follows that a circle with center at the origin, so 0, 0, is going to be given by this guy here, because if our center is 0, 0, then our h and k are both 0 here. So we're going to look at a couple examples of this. For this one, we want to find the center radius form of the circle with this center and radius 4, and then graph the circle. So if this is our center here, this tells us that h is minus 2 and k is going to be 1. And we know that our radius, or r, is going to be 4. So then in center radius form, we're going to plug this into this guy here. So x minus minus 2 squared plus y minus 1 squared is equal to 4 squared. So we'll have x minus minus 2 squared plus y minus 1 squared is equal to 4 squared. So then we'll get x plus 2 squared plus y minus 1 squared is equal to 16. And so, like I said in the beginning of the video, the only way we'll get a positive when we have a standard form that has a minus like this here is if our h is going to be negative to make it a positive. So if we want to graph this guy, we're going to start with our center, which we know is negative 2, 1. So we'll plot that. So that'll be our center. And then to get a rough idea of what this circle might look like, we're just going to extend in vertically and horizontally in both directions a unit of 4, because we know that's going to be our radius. So we're going to go 1, 2, 3, 4 units in that direction. Then 1, 2, 3, 4 units in this direction. 4 in this direction. And 4 in this direction. Okay. And that'll give us a rough sketch of what this circle looks like, and that was not the best connecting the dots, but luckily when I draw a circle it'll make a nicer one. But yes, so this will be a rough sketch of what this function looks like. Alright, So we should also be able to find the center and radius of a circle given by a function that looks like this. And so in this case, we're gonna complete the square in order to find our vertex, our HK, or our center of our circle. Sorry, not our vertex. So we'll complete the square. And in this case, we're going to need to do it separately for our x terms and our y terms. So what I mean is, first we will move this constant to this side, so we're just dealing with x and y terms on the left-hand side. And then we'll group our x and y terms together. Now, the reason why we're doing this is so we can identify our a and b terms. So in this case, our coefficient for x squared a is going to be 1, and our coefficient for x, which is our b, is going to be 2. Here, a is going to be 1, and b is going to be 6. And in this case, we don't have any c terms, and that's totally fine. All right. Now to complete the square, remember we want to divide by our coefficient of our quadratic term, but in this case it's just 1, so we don't have to do anything there. The next thing we would do is we would subtract out our c term, or add it on either side of the equation, but we don't have a c term for either one of these guys, so the next thing we need to do is add our b over 2a squared quantity. So for our x terms, our b over 2a squared is just going to be 1. And then for our y terms, we have 6 over 2 squared. So we're going to get 3 squared, which is 9. So now we're going to add both of these terms to both sides of our equation. So we have x squared plus 2x, and we're going to add 1 here, plus y squared plus 6y, and we're going to add 9 here. So we added 1 and 9 to this side, so we also have to add 1 and 9 to this side of our equation. So we'll have 15 plus 1 plus 9. All right. Next thing we want to do is factor both of these guys. So this one, we'll get x plus 1 times x plus 1. And for this one, we're going to need two numbers that multiply to 9 and add to 6. All right, and on the right-hand side, adding these guys together, we'll get 25. All right, and the last step is we're going to just write these as the square of a binomial. And we also know that 5 squared is 25, so this tells us that our radius is going to be 5. So we know our radius is going to be 5, and we wrote this in our center radius form, so we also know that our center is going to be -1, -3. Our h and k terms are here, and since these guys are positive, that means our h and k terms must be negative. So we'll do the same thing to graph it as we did in the last example. We'll start with our radius, so -1, -3. Or sorry, we'll start with our center, and then we need to move out as many units as our radius in all directions. So we'll get 1, 2, 3, 4, 5 units this direction, 5 units here, 5 units there, and 5 units there. So then our circle would look something like this, and GoodNotes is going to make the circle nicer for me. There we go. Alright, so that'll be it for this video.